Well, hello and welcome to AC's 8-Bit Zone. So today is going to be my first mail opening episode that I've had. So the idea behind this is going to be I collect up the interesting items that have recently come in, and these may be things that I ordered in the future. Who knows, maybe a viewer will send in an item or two. It's hard to say, but this is a new channel, so at this point these are things that I've ordered, and it's going to be a preview of some of the projects that are possibly up and coming. So let's get into these packages. Today there are 3 packages for us to open together, and let's see what's in here. Okay, I know what a couple of these items are. I'm not quite remembering maybe the third one. But let's see, I think I know what this is. So this is a few pieces of a buck converter, and these are really inexpensive. I think in the quantity of 4 pieces, this was something like in the less than $3 range, including shipping. The shipping took quite a while, but that's no problem. It's nothing I was in a really big hurry to receive. So here it is. Like I said, this is a buck converter, and I think its specs are something like, in the range of 30 volts in and variable and settable voltage out in the range of maybe 2 to 20 volts, something like that. I don't remember the exact specs, but let's see. So it's based on an LM2596. That's the switcher chip that's on the board. That would be this component here. And so the idea behind this board is that you can have a loosely regulated voltage coming in, or a voltage that's too high for the end system, and you can regulate down to whatever, maybe 5 volts. So in the case for the case that I purchased these, I'm thinking about doing a video about reducing the heat and the power dissipation in one of the 5-volt LDOs on the Commodore 64 main board. So let's see, here we have looks like we have the input plus and minus and the input capacitor. It's 100 microfarads. And then we have the output plus and minus and a 220 microfarad capacitor on that output. And there's a potentiometer, there's a tuning pot here to set the output voltage. So we'll take these over to the bench in just a minute and take a closer look at them. Next, this package I've recently received. I don't remember what this one was. Okay, made in China, of course. Oh, yeah. Okay. So this is going to be an 8-channel logic analyzer. These are very low cost. They're in the range of $8 to $12. I paid closer to the higher end of that just so I could receive it a little quicker. I'm not going to use it really soon, but I wanted to test it out and see if there's any value here at all. So it's just very basic. You get the little 8-channel module that looks like it includes a 10-pin connector, including clock and ground, and then the 8 digital inputs. It says logic analyzer, very generic, 24 megahertz, 8-channel. So I would assume that this can sample hopefully all 8 channels at 24 megabits or 24 mega samples per second. I hope that's the case. Hopefully they're not playing tricks where you could sample 8 channels but at only 2 or 3 megahertz each, or 1 channel at 24 mega samples. I'm not sure. We're going to try this out and see exactly what it can do. And looks like the connector to connect into the target board. These are probably often used for Arduino boards and Raspberry Pis, and with a lot of hobbyists use these. That's very cool. And I have ideas for this for an upcoming episode, another Commodore episode where assuming this works, I'm going to incorporate it into testing the PLA chip. And you know how often if you use Commodores and work with those systems, you know how often the PLAs can fail. And an idea that I had was to use this to sample some of the signals that come out of the PLA in hopes to diagnose whether it's working or not. And lastly, I know exactly what this is because it arrived today. Wow. Look at this. This is actually completely empty. When I pulled that from the mailbox today, I thought that felt a little bit empty, and I thought, it must be really small. Where's it hiding? It is not in there. This is the first time this has ever happened. But what this was supposed to be was a memory upgrade for this laptop. I've been editing these videos recently, and the laptop is a little bit low on horsepower. So it has an Intel Core i5 processor, but only 4 gigabytes of RAM. So I was going to attempt to upgrade this to the maximum RAM, and amazingly, nothing in there. And you saw it yourself. Oh, look at this. The package. I ripped it open there, but look, this package has been opened and the memory's gone. Wow. That's a first. All right, well, sorry about that, but anyway, the most interesting items, I think, are here. So let's get over to the bench, take a look at these. So first things first, I couldn't stop thinking about how the prime envelope was empty. So yeah, I'd opened it and tore it there, opened it, nothing was in the envelope, and then I had noticed that up the top the seal was ripped open at least almost halfway. So I guess the product fell out. So anyway, I contacted Amazon, I contacted the post office, and it turned out that yesterday or day before, there was a Amazon truck that had a little accident and some packages shifted, and they're thinking maybe the product fell out. So anyway, that's going to get taken care of either by Amazon or the post office. So no problem there. So moving on to the logic analyzer. I think I'd like to take a look at that first. So once again, it's an 8-channel 24 mega samples device. And I don't have anything connected to check right now, except we can look at a oscilloscope test waveform just to try to get an idea how this thing works. Okay, so I'm going to connect to channel 1 on the white wire, and ground will be the black wire. And I just have a standard, this is going to be a 1 kilohertz signal from the oscilloscope. This is the test and calibration signal that's available on a lot of modern scopes. Okay. So there's a little program that you're supposed to install, and I've already installed it. It's here. I'm at sparkfun.com, and one recommendation is to use the PulseView software. So I went there and I installed the 64-bit Windows version of PulseView. And it also recommended that you might need to come over to this link. This is at sigrok.org. That's sigrok.org. And you may need to pick up the driver. So I've already done that. Let's connect to the USB port. Oh. Okay. PulseView. Okay. 1 mega samples. So let's see. Okay, so sample rate 20 kilohertz. 20 kilohertz, so it looks like you could choose from 20 kilohertz all the way up to 48 megahertz. So I don't know, let's start at 1 megahertz. And it's choosing 1 meg samples. That would be quite a long time. That would take 1 second of data if we collected a meg sample at 1 megahertz. Okay, and it even has a little hint. It says total sampling time 1 second. Okay, so let's get, this is a 1 kilohertz test signal coming out of the oscilloscope. So let's capture maybe 2 cycles. That would be about 2,000 samples, 2K samples, and let's press run. Oh, look, here's some signal on data channel 0. I wonder if I can zoom that. There we go. Hope that's coming through on the camera okay. Okay. Let's see what else we can do. Let's up the sample depth. Let's go to 10K. Run that. Okay. There are some cursors here, and they're snappy. They're automatically snapping to, let's see if I get close to the edge, that cursor snapped right to the edge. And let's snap to 1 period, 1 cycle of the waveform, and it's saying -1 millisecond or +1 millisecond. Okay, that would be correct for a 1 kilohertz test pulse. Let's see what is the fastest sampling rate we can choose. 48 megahertz. And we'll need a lot more than 10K samples. We would need 48,000. Let's see how many we can choose. Well, we can choose 50,000. and run. I don't see anything appearing. Let me do a fit. I'm not sure what happened there. I'm not getting anything. It's automatically stopping, but I'm not seeing anything on the display. Okay, so let's try a lower sample rate. Let's go to 24 megahertz. Run that. Oh, okay. So at 24 megahertz and 50,000 samples, we're seeing about 2 cycles. Let me try the 48 again. Could it be that the 48 megahertz is just not supported by this piece of hardware, although the software supports it? Maybe that's the case, because the hardware did state a 24 megahertz capability. So that seems to be working out. No, I'm noticing that also that any of the unused channels 1 through 7, they're disconnected and they're sampling as high levels. Wonder what would happen if we connected a couple of channels to the same test signal. Let me try that next. So I went ahead and connected all 8 channels to the oscilloscope test point. Let's try running that. Alright, and as expected, all 8 channels are picking up the same signal. Okay, and it's at the claimed rate of 24 megasamples per second. Interesting. So I wonder how deep this can attempt to store at the 24 megasample rate. Okay, let's try 1 meg samples. Okay, no problem there. How about 20 meg samples? Okay, that's still hanging in there. And I wonder if we can zoom in. Okay, zoom is an easy function. Zoom in, zoom out. Not too bad. Okay, let's up the sample depth. So the end of the list here, it's claiming all the way up to 1 tera samples, which that would take a while at 24 megahertz. Let's see, what about, let's go with 100 meg samples. That should take about 4 seconds to collect. Go. Well, that was quick. Oh, there it is. Okay, that took about 4 seconds. That seems correct. And we can zoom in, hopefully. Yes. Okay, and zoom out. Zoom fit. Okay, let's push it a little deeper. 100 meg samples. Let's go for 20 seconds of data. It's still busy. I can see by the stop indicator. Should take about 5 or 10 more seconds. Okay, I think it just changed from the green indicator to the gray, and the stop changed to a run, and I see tons and tons of data there. And if I zoom in far enough, there's the signal. Zoom fit, and on the X scale up at the top, it's running from 0 seconds up to 20, 21, almost 22 seconds, which seems about right. So I don't know what the depth limitations are here. I don't know if it would attempt to keep up and send all the data over USB 2.0 to the PC and let the PC buffer the depth of data. That might be a topic for a future check or a future episode. So gosh, quick glance with this new logic analyzer, I'm pretty happy with this. The software was easy to install, it's intuitive and easy to use, and I mean, so far I'm not pushing the signal rates here very hard with this 1 kilohertz signal, but some ideas for a future episode would be to use this to look at something on the Commodore. One idea is that the PLA is always causing problems, and it might be a way to diagnose the proper working order of the PLA. Another idea might be take a look at the signal and the protocol on the IEC port. But there would be lots of things that would be interesting to dive into there on a later episode. Okay, next up we're going to move to the bench, and we're going to take a look at this buck converter that also came in. So I'll get set up for that. Okay, moving over to the bench, I have the little boardlet clamped down here. And now I'm just going to solder on some test posts. Go ahead and touch these with some solder. Okay. Sorry, the fan noise might be a little loud in the background here, but I would rather it pull a little bit of the solder fumes out as much as possible. Oops. Okay, there's a couple of test posts on the input side, and now a couple more for the output. Off the soldering iron and get this board back on the bench. Okay, so thought I would connect some amount of load, maybe if not full load. Let's connect up. Oh, here's 100 ohms. So I don't know what voltage the output is going to be set for right out of the baggie, but if it was as high as 15 volts and 100 ohms, so we might get 60 milliamps or so, which wouldn't be too much. I think this supply was rated for 500 milliamps. I'll put a link in the description, but it's the LM2596 module, and they're fairly prevalent out on the web. And I have a power supply, my handy bench power supply. It's a Dr. Meter power supply. It's a PS305, and I've set it for 12 volts. It's off at the moment, so I'll make my connections here on the input of the board. This will be the first time I've powered one of these modules. And let's connect up a meter. And I just realized you can barely see the load. Let me zoom out just a bit. And we'll place the output voltmeter over here and connected to the load. There we go. Okay, I'm going to turn on the power to the input of the module. Oh, we have a power LED and 11.26 volts out. Okay. So we're delivering maybe 85 milliamps or so to the load resistor. It's not getting very warm. Not yet. Let's try tweaking the little pot. Okay, it's maxed out. That's all it can do with the 12 volt supply. Let me go up on my bench supply. I'm at 12, 13 and a half, 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, 22 volts in and 17.69 out. Okay, now let's tweak the pot. Okay, I'm turning counterclockwise. There's about a half turn. Let me go another half turn. There's another half turn. That's one turn. 1.5, 2, 2.5, 3, 3.5, and 4, 4.5, and 5. And for the future project that I have in mind for this little supply, I'm probably going to run it at around 8 or 9 volts. There's 7. Let's see how low we can go. Practically the lowest I would probably need this for would be maybe 3.3 volts. Let's see how it does. Okay, no problem. 3.3. Still going. Still going. Okay. We bottom out at 1.242, which is probably the regulator's threshold voltage. So 1.24, and I'll leave this set for about 5 volts for now. Okay. The load resistance is still not very warm. I mean, it's warm, but not hot. One more thing I'll do just before we move on is just add a little bit more load in parallel with this one. So here is I already had a 100 ohm there. Here is an additional 332 ohms. So the combination of these two is probably somewhere in the vicinity of 80 ohms. And so I'm just going to clip it on. We might see a little spark, but I'm curious if we'll see much of a perturbation on the DMM, or will we see a loading effect? Let's see what we get. So 5.021, and clipping on the additional load. Okay, not much going on there. So it regulated and changed very little. If I remove the load, very little change. So it's regulating, and on a future episode we'll take a deeper look. We'll connect the oscilloscope and take a look at the noise levels and the ripple, and do a little bit more with this supply. But right out of the box, this seems like as advertised. And again, I'll put a link in the description so you can go check this module out, or just Google the LM2596. Okay, moving on. So if you haven't already, go ahead and hit that subscribe button down in the lower right, or even down below. And I have some upcoming videos that will feature some of the items you saw today. Probably won't do anything immediately with the power switcher or with the logic analyzer, because first I want to show you the 1541 Model 2 disk drive and power supply, and that's probably going to be one of the next videos that will be coming out. So go ahead and subscribe and hit the bell, and you'll get an immediate notification when those videos are up. But for now, that's it, and I hope you enjoyed the topics for the day, and maybe got a sense of some of the types of videos that I hope to bring out in the near future. Thanks for watching, and have a nice day. Bye.